Okay, so we're looking at exercise 11D from the first year mechanics textbook, and we're on question 5. So a particle is moving in a straight line. We're given its velocity in terms of time. We're told the initial displacement is 0, and I'm asked to find the distance between the 2 points when P is instantaneously at rest. Okay, so I am going to need to integrate to find displacement. I think I'll actually just tackle this first, though. So find the distance between the 2 points where P is instantaneously at rest. So it doesn't sort of matter which order you do this in, but I am going to need to find when it's at rest. So there's my velocity. So it's at rest when V is 0. So I'm basically going to solve that quadratic. I'm going to be lazy and just stick that straight into the calculator. Okay, so that gives me T is 6 and T is 5/2. Check I typed that incorrectly. Yeah, that's fine. So T is 6, and T is 5/2. Okay. Right. So that's the 2 points in time when it is instantaneously at rest. But they're actually asking me about the distance between those 2 points. So first thing I need to do is find an expression for the displacement. So displacement is going to be the integral of velocity. So 6t squared minus 51t plus 90. So that's going to integrate to t cubed. I'm going to divide by 3. That's going to integrate to t squared. I'm going to divide by 2. 90t, and then don't forget plus c. So when t is 0, the displacement is 0. So again, you might well be able to just spot that. So let's just using this information here. So that when t is 0, s is 0. So you can pretty much tell from that c is going to be 0, but still you do still need to acknowledge c and sort of show that you have worked it out to be 0. You haven't just forgotten about it. Okay, so I've got my full equation for displacement. Okay, so c is just 0. So it wants the distance between the 2 points when the particle is instantaneously at rest. So it's first at rest when t is 5/2. So if I get its displacement at that point, I'll stick all this straight into my calculator, but just to show some working. So I'm just substituting t is 5/2 into this. Okay, so let's just quickly stick that into the calculator. So 2 times okay, so I managed to just double check that when we check the answers, but I'm getting that to be 96.875 meters when t is 6, s is 2 times 6 cubed minus 51 times 6 squared over 2 plus 90 times 6. Okay, so quickly stick that in. Okay, so I'm getting 54 for that. So the question was the distance between those 2 points. So let's just check what we get there. So the distance between, so that was they're the 2 displacements. So the distance between them is going to be 96.875 minus 54. So that gives me, so to three significant figures, that gives me 42.9 meters. I'm just going to check that in case I type something wrong into my calculator. No, that's good. Okay, so the overall method was I chose to find the 2 points when it was at when its velocity was instantaneously 0 first. You might have come back to that later in the question. Then I integrated to get my displacement, not forgetting to find the value of c. Then I found the displacement at my two values of t, and then the distance between those two would be the difference between them.